Hello. My name is Thiery Laverdure, and I am the founder of Space Studio. So I started the company 2010 when I was in college, and it's a once upon a time web and app development agency that's now turned into a solopreneur, building startups and consulting on the side kind of deal. I live in the Metro Atlanta area, and I'll pull my picture up. Look at that guy. I live in the Metro Atlanta area with my wife and three sons. I've been a Laravel developer for, I don't know, probably as long as I've been a developer almost. I started a little bit with PHP outside of Laravel, and then quickly found it as my go-to solution. On social media, you can go to my website. There's nothing there yet, but if you want to sign up for my newsletter, you can. I'm on Blue Sky at terrylaverdure.com and GitHub tlaverdure. So when I get nervous, I tend to turn to humor a little bit. So I've built in a few humorous slides. So when you see them, please humor me. I'm recording this, and my kids, if you guys laugh, it'll make me, look popular. All right, so today's talk is titled Protocol, and we're going to be talking about building a bi-directional streaming protocol with low-level PHP/HTTP. This is something that I've kind of been experimenting with for a project that I'm working on. I guess I'll take a quick dive into that real quick. So I haven't released the project yet, haven't talked about it. This is probably the first time I've talked about it to this many people at once, but I'm pretty much building a SQLite database server that allows you to access the database over HTTP in a streaming fashion. So you access the database by using a client that will pretty much send queries, send transactions in a streaming fashion, so you can interactively call your database over the network. So this is an idea that I've had over a lot of years, since 2020. And over the years, I've seen companies like Terso, Cloudflare, to name a couple, that have come out with similar solutions. And rather than get down about myself by, oh man, I should have released that, that was my idea, I'm kind of to the point where I'm like, hey, there's actually people that will use something like this, because I think that's kind of where I felt years back. So with that being said, PHP is not a low-level language, as we all know, like Rust, C, Go, but you can do some low-level things with it. It's a higher-level abstraction. Frameworks like Laravel, Symfony, they're a higher-level abstraction on top of that. But everything that we use is kind of built on top of this really low abstraction of HTTP, which I find kind of interesting. So we're just going to discuss some of the concepts of HTTP before we get into the client side of things, where I'm going to be building. So internet, everybody love the internet. That's how we make our money, bread and butter. The internet, as we know it, is made up of four discrete layers. There's the link layer, the network layer, the transport, and then there's the application where we do most of our work. And when you access the internet, these are the components that you're interfacing with. So the link layer, as you know, it is hardware, physical switches, routers, all the things that are on the actual host. The network layer being the IP addressing, NAT, gateways, routers. There's some people that geek out about this stuff. I don't particularly, but it's good to know about how it works. And then the transport layer, the end-to-end communication. Once the two hosts are up and running or are connected, how do they communicate? And then the process-to-process communication happens at the actual application layer. And these are just some more common names for these things: HTTP, TCP, DNS, IP, LAN, WAN, local area network, wide area network. And when you think about using the internet, it's a decentralized protocol, and there's a lot of hype cycles, a lot of tech hype cycles. Let's say like Web3, we're not really, I mean, you could kind of say AI is kind of one, there's different cycles within the AI movement, but I think it's definitely a shift in different software, paradigms in development and how we use it. But, the internet is one that stands, and it's always been decentralized and continues to be decentralized. When a host on one end, wants to communicate with another host, it has to go through this process of pretty much mapping out how it's going to connect to another host by reaching out to the local area network. So my physical computer has to go to a router, which has to go to a local area network, which goes to another wide area network, which goes to another wide area network. So there's a whole bunch of hops that are happening. If you've ever, done like a TCP trace or looking at all the packets, all the different, IP addresses that are hopping all over the place. So basically, you're looking up, these two services, the link layer and the network layer, working together, to find how do I get from point A to point B, and then once I've gotten from point A to point B, we're going to create or we're going to negotiate and say, hey, let's open up a connection so that we can chat, and then our applications can then talk to each other. It's really interesting when you really think about, the vast networking that needs to happen, this vast system that we've created that's decentralized, that's been around for decades now. And interestingly enough, when we talk about today's topics, which are going to be HTTP, binary data, asynchronous execution, and bi-directional streaming, one of the most interesting things to me is that with HTTP, there's been very few versions over the years. 96 was when HTTP 1.0 was published, and there's been, after that in 99, 1.1 was published, and then there was 2.0 which came in 2015, and 3 in 2017. So again, you can see kind of like by the span of those years, version 2 and version 3 is kind of like these little, I don't know, maybe we got it wrong. Maybe it was a hype cycle and we're like, all right, we got to go to the next thing. But interestingly enough, 1.1, it has the most adoption. It's mostly used with your clients and your networks, or your clients and your servers. So that's what we're going to be talking about today. Binary data is something that we typically don't use when we're building web applications. But I want to use binary data because it has the ability, or I have the ability to control the data flow, how it's structured, and not necessarily have to worry about sending extra data or there being any overhead in terms of how it's transmitted. Asynchronous execution is a goal of mine. So when I'm communicating from a client to a server, I'm thinking there's an opportunity to pool the sending capacity of the client. So a client, when I say client, think of it as a server. Your actual users would hit your web application, they'd hit your server, and then we can open up a connection. And then on that connection, we could jam in a whole bunch of requests, to the actual database server. And then bi-directional streaming is, the interactivity, because when you're using a database, you have to have this interactiveness to get the transactions to work. You say, open a transaction, and then from there you say, hey, let me read this row. And when you open that transaction, it should not, change, or you should see a specific, snapshot of the database in that state. So things need to happen really quickly so that you don't, run into a position where, everything's out of sorts. So why? Why even do this? Why even think about doing something like this? I felt like it. I was interested. I think it seemed like a cool idea at the time. But there's also a lot of protocols out there that already exist. SOAP. You guys remember SOAP? I think you guys do. REST, WebSockets, GraphQL, gRPC. So why not use one of these more well-established, well-adopted solutions? So I'm looking for high efficiency, low throughput. High efficiency with low footprint and low complexity. I want high throughput, not low throughput. So in terms of JSON, anything that's JSON structured, one of the things that I kind of figured out, which is what I started with first, and as I tried to ramp up the requests per second, I noticed that on the database, on the server side, I was losing. I was looking at my profile and I was losing efficiency based on the amount of time I was spending to serialize and deserialize JSON. If you don't, you guys know JSON. It's pretty much JavaScript object notation, and if you know JavaScript, JavaScript was created by mistake, so JSON is, a child of JavaScript. But what that means is that whenever you send this JSON over to a server, it has to interpret it. It's not necessarily fully typed. We have to guess: is this a number? Is it a string? Is it an array? We got to, look at all these things, look at these patterns, and figure out what it is. So that's one of the reasons I was like, okay, this is probably something that needs to go. And you're always sending those extra characters, those squiggly marks, the brackets and stuff like that. That's extra stuff that you will need to send. What about WebSockets? One of the things I didn't really like about WebSockets is that you have to establish a long-lived connection. You can establish short-lived connections, but there's a little bit overhead there. You require, that constant resource usage, to keep the connection open. And then it's also harder to load balance. When you have a WebSocket, it's not easy to balance it across multiple servers because it's a stable connection. So it's a little bit more trickier. And then there's like gRPC, which, I don't know if you guys have ever used it before. It's pretty much, it's a newer type of standard, or not really, I don't know if you would call it a standard, but a programming technique where you use a protobuf to send, structured data. So you pretty much use the specification to generate, these are the data structures, these are the functions and how they interact with each other, messaging basically, and then you generate this protobuf, and then you can use that, you can ship that to different languages and stuff like that. But the trade-off there is that you have to have, or in our land, PHP, and for other languages, you have to have maybe an extension or additional software. So my goal was, how do I spin this up, for multiple development software programming languages? And I think the common denominator is just doing it over HTTP. It's easy. Easy is maybe probably not the best term, but it's most accessible, I think, in a lot of software languages today. So the design goal is high efficiency, low complexity, and that means assuming full control down to the byte level so that we can control bandwidth, latency, and throughput. The last thing I want to share on the topic of why is a meme that you guys probably have seen out there on Twitter. My father-in-law is a builder. He is insanely gifted. We were in a cathedral together years ago, and I asked him what it would take to build it today. I will never forget his answer. We can't do it. We don't know how to do it. And I think it's increasingly becoming more. I mean, you could say a lot of people have made fun of this. They've taken pictures of like McDonald's and stuff like that, and they've said, we don't know how to do it anymore. But I think if we were to take a snapshot, of where we are today and the next generation of developers, I think we're kind of in a scary place with AI, with search engines, with just the immediacy of, hey, I want this, make it for me. We have all these tools that can do it for us. And I think we're losing, today craftsmanship is in decline. And if we are not careful, I think we're at risk of losing, the wealth of knowledge that has come before us. And we're not gonna have anything to share because, my kids, they're glued to YouTube today. It's like everybody wants to be a YouTuber. Everybody wants to use AI for the, 5-minute, startup. And I think it's important for us to just try things and figure out how to do them ourselves sometimes. Roll up our sleeves and do it even if it already exists out there. So if you haven't heard, I am going to be speaking at Laracon this summer. Here I am on the website. And I know what you guys are thinking. How did they get a keynote speaker of Laracon here tonight. No, really, honestly, I'm extremely grateful to actually be on the stage, and I'm actually not even at the top of the page. I'm way down there. I think I'm really nobody, I'm gonna say sorry to Joe. I put my picture in his place. But the talk that I'm gonna have, my talk is gonna be titled at Laracon, Why You Should Reinvent the Wheel. And I'm gonna be talking about pretty much overcoming imposter syndrome through the exercise of finding something that's already well established, finding a package, finding a project, something that you're passionate about, and just diving into it and doing it. Because who cares? You'll learn something from it. You'll become better from it, and who knows? You might come out the other end and create something that's even better than the previous wheel that was out there. People that did not dare to reinvent the wheel, we wouldn't be driving on rubber tires today. We'd be driving on stone and whatnot they used in the past. I don't know. I'm not old enough to remember all that stuff. So let's talk about the design of this client. Again, the goals are to send over HTTP, transmit data, binary data, stream messages, and handle multiple messages concurrently. So here's a question for you guys. Should we be using the hypertext transfer protocol to send binary data? The answer is in another question. Should we be using a language originally named personal homepage to build web app servers and CLIs? Huh? Well, yes, of course. I mean, naming things is hard, guys, all right? So I think when they initially designed the HTTP protocol, it was for a hypertext, the HTML language, hypertext media, or markup language. I don't know why I got HTTP media. HTMX is in my brain for some reason. But the same thing goes for PHP, initially designed for probably one particular use case, and over the years it grows and it develops. Now with HTTP, you have ways to define the request and say this is the type of content that it is. So we'll just take a quick look at what it is to send HTTP over the wire. And honestly, it's all text. It's just a whole bunch of text in a structured way, in a specific order that's predictable for the client and the server so that they can interact with each other. And we have our start line here, which defines the method, the path, the protocol version, so that you always know, like, okay, this is how I should handle the request. And then from there, you can send different types of headers, like the host, which defines, all right, this is the virtual host that this server should be handling. You've got the content type, like we just discussed, that identifies what type of content is actually being transmitted. And then our connection header, which is important, which we'll talk about, which describes, should this connection be remain open or closed. And the content length, where a client or server can hint at to the receiver of the data how long this data is, because we don't want to just continue reading longer than we need to. We just want to get the exact information. And then you have your body. Here's some JSON for you guys. I don't know if can you guys guess the song? You guys know the song, right? All right. So, and the HTTP response is similar as well. We have the start line, and you can send arbitrary stuff like the date, when it happened, content type, length, and body. All right. So, first we'll talk about short-lived connections. So this is kind of like where my approach kind of first started, where, all right, let's just send a request and see what happens. The problem with that is if your client and your server are not set up properly, then you'll run into performance issues because, in the HTTP 1.1 specification, connections are keep alive by default, but you might run into some situations like in the 1.0 specification where connections were closed. So what that means is, when you're sending a request from your client to your server, you open up a connection, you send a request, you send a response, you notice that the connection gets closed. So that means that you have to go through that whole process again, opening up a TCP connection, and then you can go ahead and send another request and get your response. So then, 1.1 introduces a concept of persistent connections where we keep them alive. So after the request is done, the actual operating system knows not to, close the connection off so that we can continue using it, or we might want to continue using it. And there's some ways that you can configure this to time out, at a specific, amount of time or whatnot. But in this situation, you'll see here, that it's a lot more fluid for us so that we can continue our work. We request, we respond. We have our boundary here for another request response, and then we can close the connection when we're done. So the latency of closing the connection and having to restart that process, it disappears. So I started doing some more research. I'm like, all right, this is good. I think we're getting somewhere. And I discovered pipelining. Has everybody ever heard of pipelining with HTTP? Yeah, it's a concept that was out there for a little bit, and then they shut it down. They were like, oh no, we didn't want that to get out. It wasn't in browsers, it was in Firefox, it was in Chrome, but then they kind of deprecated it because it created more issues than it solved. But pretty much in this situation, what your goal is to do is to open a connection and send asynchronous request. That's with an asterisk, because what happens is you're going to send your request out without waiting for a response, and then it's the server's job to respond in the same order that it received the request. The issue here with this is that while you have your client sending, or you have your connection open and you have all these requests in flight, you have to wait for all of your responses essentially to come back before you can continue on with your program. So it's kind of blocking in a sense, and the end-to-end latency is as fast as the slowest request in this situation. So I kind of tabled that. I was like, I don't think that's going to be the solution. But then I started thinking about streaming. If you guys have ever used server-side events, this is where I kind of went down this path where I was like, there's always this server-side events thing where you can just, do a GET request, and then the server can just, spit stuff out, whenever it's ready. So you're just kind of streaming data. And I got exposed to this, I forget what exactly I was doing, but it was just interesting to me where I saw a demo online, and you reload the page, and then one line of text came on the screen, and then a second later, another line of text. I was like, whoa, this is crazy. But interestingly enough, when you open the connection, you actually have the ability to send asynchronous requests. You can send a request, and then you can send another one, and then you can send another one, and the server can then stream the stuff back to you, as it feels like, And this is not something that's typically talked about, but really what we have is an open TCP connection, and we're kind of then blurring the lines of the protocol because they want you to use it one particular way, but you can do what you want with it. You open the connection, you send your request, the server's gonna stream them back to you as it sees fit. All right, so let's talk about our next topic. Who can read this for me? Are you serious? You know what that said, binary? That's what it says? Are you serious? All right. So, binary is our next goal here. Has anybody ever used the pack method? Oh, we got one. Yep, so you can encode your data in PHP with this method here. So there's a lot of different options in terms of the type of data that you're inputting and the type of the type of data that you're inputting in terms of how you want it to be represented so that it can be decoded later on. But here we have an unsigned character, an unsigned long. This one is in little endian format. Don't ask me to describe what that is. I just know that the numbers are read from right to left. But here we have our encoding and decoding of the data. And this is kind of how my protocol is going to work. We're going to take the data that we want to send, say, for example, a statement string, and we are going to count how many characters are in it, get our length, and then we'll get an output of that. We'll also get the number of bytes, in the string for the statement, or for each parameter, we'll have to go in and count how long is each parameter, maybe even include what type it is and stuff like that, and just create all the information that we need. And then I came up with this concept, which is kind of similar to HTTP2, where you have these frames of data. So the reason that I wanted to create this binary message framing is kind of a system to where you have this envelope to send all your messages in. So think of a frame as a vehicle for these messages to get to the server. So there's a frame, and then within a frame, there's multiple entries, and then the entry actually has the message. So the goal, right now I've got it working to where only one entry is in a frame at a time, but the goal will be as the server is accepting the messages, it'll fill a frame with X amount of entries and then ship them off to the server so that it can amortize the latency that's required to send all those messages, across the network. So we basically in PHP define the different types of messages that we have. This one right here is 1, 2, one for the frame, 2 for the message entry. So we'll start off by accepting our message. We'll say this is the type of message that it is. It's an entry. This is our message that we're trying to send over, hello world. The length, we'll just encode that as well. And then basically we'll just concatenate them all together to create our frame entry. And then we're going to also do the same thing for our frame message type. We'll take that and we'll concatenate it down here with the frame length. And so you can kind of see we're working our way backwards to create this envelope kind of system to encapsulate our message within a frame, within a frame entry within a frame, so that when it gets to our server, we know that, okay, the binary data is coming in. First thing we need to do is find out what type of message it is. It's a frame, okay. The frame is this long. That means that the first one is going to be we need to look at the first message, frame entry, see how long it is, and read it till it's done. And if there's another, we know the full length of the frame bytes, so that we'll just continue reading, just looping over that, so that we can continue reading our message. So it's a very simple protocol in that when the message is transmitted over the wire, it's received on the server. There's not a lot of deserialization or anything for that matter of fact. We just need to count bytes, figure out what type of message it is, and then put it into the data structure that we need to execute our database queries on the server. All right, well, thank you everybody. Appreciate the time.